So my name is Tomasz Janczuk. For the past 2 years I've been working at Auth0, focusing primarily on the development of the webtask platform. And today I'd like to talk about platform extensibility, webhooks, and how serverless can change the dynamic in this space of platform extensibility. So when you're developing, when you're writing a web platform today, frequently you have to ask yourself a question of to what extent do you want to customize it. So many different platforms have a very simplistic view of customization. You may have a blogging platform that allows you to change the theme, for example. Other platforms have a certain set of toggles, radio buttons, and drop-downs. However, some platforms, especially the programmatic platforms, have a much more complex customization needs. One such platform is actually Auth0 itself. Auth0 offers identity management as a service. That is our primary product. And security in general and identity authentication are, generally speaking, complex areas. So radio buttons, checkboxes, and kind of declarative forms of customization can only get you so far. At a certain point, you have to, there remains a very long tail of customization scenarios, things that people would like to tweak about your platform that is not possible to do in any other way than by writing custom code. So typically what happens at that point is that people start exposing webhooks. If you look at a webhook, this is an ideal mechanism to enable a platform to be extended via custom code. It is a great mechanism because it kind of, on one hand, allows you to decouple two systems, the platform that is being extended from the endpoint that actually implements that customization, with a layer of a very well-defined protocol. So the piece of logic that implements the customization is also encapsulated. So it doesn't really matter what technology you are using. It may be a completely different technology from the core platform. As long as you comply with the protocol that the core platform expects from that extensibility point, you are fine. So two examples of such platforms are GitHub. GitHub offers a number of webhooks for a variety of situations. Same can be said about Slack, and frankly, any major platform out there focuses on webhooks as a mechanism to extend its core functionality via custom code. So webhooks are great; they are super flexible. Everybody loves them, but speaking in this audience, webhooks of course suffer from all the problems that serverless aspires to solve. So. As a person extending a platform using webhooks, you have to take care of all the concerns typically associated with running a service. So you have to find a place to host it, SSL certificates expire, scalability, maintenance, possibly separate billing from the core platform, and so on and so forth. So all that list of problems that serverless trend aspires to address. As a result of all these aspects that a developer extending a platform has to think of, some of the things simply never get done. If you look at any extensibility scenario from the perspective of two parameters, the value of doing that work and the cost of doing that work, there is always some kind of a function that describes, that kind of divides the features that will get done because the cost to benefit ratio makes sense for them from the features that will never get done because the cost just outweighs the benefit. And quite frequently, your favorite feature falls on the wrong side of the fence, and as a result, it never gets done. So at Auth0, we started thinking about what can we possibly do better in this space. It was our own problem. We wanted to expose extensibility through custom code in the core Auth0 platform. And we ended up coming up with the idea of webtasks. So we can think of webtasks as a replacement of a webhook. Instead of asking developers to write code in some other place, take care of hosting it, scaling it, and so on, and giving us a URL to invoke that code, we allow them to actually write that very code on our platform. So what this does is, on one hand, it removes all the concerns related with hosting from the developer's plate. On the other hand, it moves it onto our plate. So suddenly we are in a situation where we are operating a multi-tenant platform. Each of our tenants can write a custom snippet of code. We don't know what it does. So we have to have a mechanism that allows us to sandbox execution of that code. Execute it in an environment where one tenant cannot affect the code of other tenants. There is some resource governance in terms of CPU, network, memory, disk utilization, and so on. So in other words, we are writing a platform. We call that platform a webtask. We've been working on it for the past 2 years. Probably 20% of that time was spending actually writing it and 80% stabilizing it, which is one lesson I learned. There is a huge gap between software and a service. But as a result of that work, what happened is we actually enabled our customers to do more, simply by reducing their cost of delivering customizations. So given a specific feature that they had in mind in the past that would be in that category of it will never get done because we have to take care of all these server-specific concerns, the value of that feature remained constant, but we have reduced the cost for them, and as a result, a lot more customizations got done. From our perspective, it was a win-win. Our customers were winning because suddenly they could let loose and really customize our product to their needs. For us, it was a big win because, as it turns out, customization through custom code is the #1 platform attach. Once people start customizing your platform through custom code, it is actually very difficult to leave that. So once we have solved that problem for Auth0, we started looking at that entire space of platform extensibility and wondered if we can apply a similar principle to other places that are using webhooks today. So in essence, the problem can be phrased as, given a piece of code, what is the simplest way to turn that piece of code into an endpoint? Because once you can do that, you suddenly enable everybody who wants to implement a webhook to do it in a very efficient way. So to that end, we have designed 2 experiences. One is command line based, and another is web based. And I'll just quickly demonstrate what you can do with the webtask platform today. So let's assume that that very simplistic implementation of extensibility point, which does nothing more than just returns a hello world back to the user. So how do we take this piece of code that sits on my local disk and turn it into an endpoint that we can potentially plug into some platform that expects that interface? So we have WT command line tool. This is part of the webtask platform. It enables you to perform a number of operations on web tasks, but the primary one is called create, which allows you to actually turn a piece of code into an endpoint. So I'm going to take that hello.js file that you just saw a moment ago in Sublime and hope that Wi-Fi works, and it does. And it is turned into an endpoint. So I can now take that endpoint and call it with curl. And hello comes back. So this is the kind of the very simplistic mechanism that allows you to take a piece of code, turn it into an endpoint without concerning yourself with any of the aspects traditionally associated with hosting code. So find a place to host it, SSL certificates, scalability, maintenance, and so on. So this in itself already enables people to very quickly implement a webhook on any platform that exposes webhooks out there. Let's have a look at the programming model. So again, this is a very simplistic, unrealistic example of what you may want to do in a typical webhook. Normally, very frequently, when you're writing some kind of a backend code, you will have the need to reach out to some downstream servers. So it may be a Mongo database, it may be Twilio, because you want to send an SMS message. It can be bottom line is that whenever you're doing something like that, many of these scenarios require authentication to some downstream resource. So to connect to Mongo, you have to have a username and password. To connect to Twilio, you have to have API keys. In general, how do we manage those secrets in the webtask world? So we have actually built in secret management right into the platform. And in order to get at the secrets that you can specify at the time you create a webtask, you have to use the second signature that webtask supports, which in addition to the callback also takes a context parameter. So So once you accept the context, the runtime will provide all the secrets that you have configured at the time you create a web task on that context object. So you can get at them with context secrets, and let's call my secret my key. So now, I have code, and obviously I don't want to bake any secrets directly in my code. This is bad practice. The runtime will provide the secret to me only when my code executes. So my secret will never actually be stored in plain text on disk. Now let's go back and create a web task that actually specifies the secret. And this is as simple as specifying as my key. We can say ABC. So I've recreated that web task, but this time I have associated the piece of code with that my key secret, which value I specified on the command line. Again, that data at rest is encrypted and only decrypted when the actual web task executes. So let's go ahead and execute it. And you can see that what comes back is hello colon ABC, which is exactly what we have requested to be sent back here. So this is a very simple example of secret management. Web tasks also support a third programming model, which has a very high fidelity with the HTTP protocol. And this looks like this. So in essence, conceptually, this is pretty much a moral equivalent of the HTTP handler in Node.js. But in addition to the request and response object, which allows you to operate on the request and response as you would normally do in Node.js, we also provide the context object, which specifies the secrets and other utility functions on top of it. So from here, you can, for example, do res write head. We're going to return 200 and content type text HTML. Okay, so this will return a header in HTML that will contain the word hello. So let's recreate this web task. We don't need a secret because I got rid of it. And now I can go and open this in the browser. So bottom line is, given the high fidelity of the web task programming model with HTTP, it is not only useful for operating on data. You don't only have to, you can return not only JSON but also HTML, which makes web task usable for very simple UI application. We think of it as kind of a mini apps, something that would be a moral equivalent of a single function that Serverless is trying to promote. You can think of a very simple UI interactions that literally, for example, present a form, collect some user data, and do a post back to the same web task to process that data. So you can do a lot of useful interactions using those simple pages. For example, you can accept a Stripe payment this way. So this summarizes the command line experience of creating web tasks. We also have an IDE web-based experience to come with it. In order to switch to that experience, we are now going to open up that IDE using wt-edit, and we are going to edit that very web task we have just authored. So this pops up into the browser and opens what we call a web task editor. So web task editor allows you to do many of the same things that you can do via the CLI. You can edit the code of that function. I'm going to revert it back to the previous signature. It also allows you to specify secrets to go with that code using that key element here. So we can add our secret, set its value to foo, the key to foo, and the value to bar. And we can then use that secret using that context parameter here. Secrets foo. Now, the one last thing that the web-based experience integrates really nicely, that you can also do via WT-CLI, but in less integrated fashion, is integrated logging. So we have real-time logs that are streamed from the backend where that code actually executes. So anything you do with console log here, make a new request, will be automatically streaming to the logs when I execute this code. So let's run it. So you see new webtask request showed up. This is the entry that was generated by console log. And what comes back is hello undefined. Oh, I didn't save the secret, that's why. So let's run it again. What comes back is hello bar, which is the secret I extracted from code. So this is the web-based experience of authoring web tasks on a web task platform. So if you take it all together again, what we have just done is we have taken a function written in Node.js and very quickly turned it into an endpoint that you can go and plug into any of the platforms that expose webhooks as a primary extensibility mechanism. So with that, let's take it up a notch. How many people here are using Slack? Everybody. So Slack is the new email, and frankly, within Auth0, Slack has replaced email pretty much completely. We are only using email for communication with customers anymore. A lot of the life within Auth0 is centered around Slack. One reason for that is that we are a very distributed company, so we have to have a common communication medium. But over time, beyond just human-to-human communication, Slack has also created a replacement for many of the processes that were satisfied using other means before. So we are very heavily invested in chat-ops in Auth0. We write a lot of integrations for Slack that are very Auth0 specific. We can deploy entire clusters of infrastructure. We can provision new employees simply by issuing commands on Slack. Just to give you an idea of what we do in Slack today, you can, for example, go and do a report on signups, which goes to the database, fetches the most recent signups for the past 10 days for one of the systems that we have, and presents it as a Google chart. You can do many other things using chatops command. As I mentioned, you can deploy entire clusters of servers and so on. Now, if you look at this scenario of extending Slack to deliver those commands, it is not that different from the very same problem we had in Auth0 2 years ago. So typically what you need to go through is when you're implementing a command like report, you have to go to the Slack management dashboard, declare that command, and the crucial piece of data you have to provide is the webhook URL. And from that point on, as a developer, you are on your own. So again, you face that problem of let's find a place to host that code, SSL certificates, maintenance, and so on and so forth. And you have to go and solve that problem over and over again for every single command that you solve. So we looked at this, and we looked at web tasks and asked the question, can we do something better here? And as a result of that, 2 weeks ago, we've put together kind of a meta integration for Slack, a moral equivalent of the WT-CLI command, which enables you to not only execute custom Node.js code via Slack, but also author that code right from Slack. So let's have a look at how that experience looks like. So we've introduced the WT command. And as you can imagine, it is a moral equivalent of the WT-CLI command. So it enables you to create new integrations and run them right from Slack. So let's make one for starters. We'll call it hello. So we have just added a brand new / command to Slack. No servers, no hosting, no SSL certificates, and we can just run it. Did I create it? Oh yeah, now I create it. And you can run it. So what it does for starters is just responds with a hello and whoever called that web task. So nothing super exciting. But one thing we can do is we can start editing this command right here using that link, which pops up into the web task editor that you just saw. It provides some large command that explains what you can customize, explains a little bit about the payload you're going to get from Slack itself. And the actual code really boils down to this. So what you are seeing is that we are sending back a JSON object, which is the payload that Slack expects, that specifies what Slack should display back in that channel where that command was issued. In this case, I'm simply saying hello and responding with the username of the user who invoked that command on Slack. But I can very quickly change it to say serverless. I'm saving this, going back to Slack. And when I call this command now, I'm going to get back serverless. So this pretty much reduced the DevOps effort of creating new / commands to Slack to pretty much zero. Once we shipped this within Auth0, one thing that happened is it caused an explosion of innovation, simply because we have moved on that cost spectrum. We reduced the cost of adding new customizations to Slack, and many of the hidden desires people had for, oh, it would be nice to have a / command that does foo or bar, suddenly found a path to realization. So some of the things that people have built, we have a data scientist on the team, a person who's responsible for maintaining our data warehouse that consolidates all the data about all customers and all events on all websites, pretty much everything we know, into a single queryable database and extracting knowledge from that. So one example of a web task that he has built that he integrated with Slack is called WT Lead. So what WT Lead does, it allows you to specify an email address of a person. I'm going to put in myself here. It will go and mine that huge database and generate a report about everything we know about that guy. So some things that you will see is, there are some attributes that have a certain meaning to our marketing team. There is a role, I'm supposedly an engineer. What was the first website that I've seen? There are two interesting pieces of data, fit score and behavior score, which for us describes the likelihood that person will become a paying customer based on his past behavior. So given that the entire life of the team revolves around Slack, this data scientist, given that reduction of cost of delivering those customizations, was able to empower everyone who's on Slack to very quickly find out what we know about a certain person. So especially you can imagine the sales team was quite happy with this. They can literally sitting on the phone talking to someone, they can find out what we already know about them. So this is one example. Another one is in support of DevOps. So serverless is great for the end user because they don't think about servers, but as a platform operator, we of course are on point to maintain those servers. So we are trying to make our own life easier by giving us tools right on Slack that make it very easy for us to perform the common DevOps operations. So one of them is finding out the status of systems. So you can do WT status. And let's say we are interested in the status of the Auth0 subsystem. And what it tells us that there are 3 major deployments in Auth0, US, Europe, and Australia, and all of them are green right now. You can query for many other systems in a similar way. You can find out if we have any current alerts in the system as reported by our health monitoring system. And you can see that all systems are green right now, no failures, no warnings. So these are some of the kind of more useful applications, but once this showed up, there are of course a number of pranks going on. So one of them, sometimes when you have a heated discussion about a design issue on Slack, those emoticons only get you that far in terms of expressing your feelings. So people went and implemented something called WT slap. You can slap someone, and I'm going to slap my colleague, Glenn Block. So what this does, it slaps him with a big trout. I didn't do this, someone has done it. It created some enjoyment on the team. Another interesting aspect is when we have a failure in the system, something is going on. The first reaction of the team is, of course, everybody goes to a specific channel on Slack when we coordinate our next steps. Frequently, so first of all, it doesn't happen frequently, but when it happens at night. So on those occasions, you sometimes have to go and wake someone up, someone who's asleep. And the best way to do it is via an SMS. So we have a web task that does exactly that. You can do WT wake up. I'm going to wake up myself right now. You can add a message. For example, the sky is falling. So what this does, it's a very simple web task. It just wakes me up, and I just got an SMS, the sky is falling, from myself on Slack. So without leaving Slack, which is where most of the people are at the time, you can just go ahead and send an SMS to anyone. Very simple application, but in those cases where things are going down, any kind of second counts in terms of switching applications, finding contact on the phone, and so on. So we just integrated it right there in Slack. We have a little directory of contacts that is using Slack usernames. So with that, let's actually have a look at how that logic is implemented for the wake up. This is small enough of a web task to kind of help us understand the principles of how things are built. So I'm going to edit the wake up web task, which gives me back the URL to the web task editor. So let's have a look at how that code looks like. So first of all, we are going to use Twilio to send the SMS messages. This is the little directory of phone numbers. So we are mapping Slack usernames to phone numbers. And then this is the core of the function. So again, we take a context and a callback. First thing we do is Slack, when Slack invokes this webhook, it will provide us details about what was typed in the command in Slack as part of the body of that request. So the first thing we are doing is we are actually parsing this command. You'll remember when I was in Slack, I said something like WT wake up, Tomek, and some message. So what Slack is going to give us is basically this part as a command. So we have to take this string and parse it into the individual parameters, which is what happens here. We are applying that regex expression, take the first word, and assume this is a user, take the second, everything that remains after that, and this is going to be the message to send to that user. We are responding to Slack immediately with waking up user such and such. This is because the processing model behind /webtasks is that you only have 3 seconds to respond. If you don't respond within 3 seconds, Slack will consider your command failed. But one thing you can do is you can respond immediately with I'm working on it, and then asynchronously post back to that Slack channel even after 20 seconds with some other result. Given that we are making an outbound call to Twilio here, we don't really control the entire time that request is going to take. So what I chose to do is I'm responding to Slack immediately with waking up and a specific user. And only then I start sending an SMS message using Twilio to that user. So from that point on, we just create a Twilio client using the Twilio seed and auth token, which is taken from the secrets. You can see that these two values are provided here in secrets at the time that web task was being created. We are formulating the SMS message, so the body is going to read from and whoever issued that command on Slack. This is populated automatically, and this is followed by the message that user has typed in. We are fishing out the phone number to send that SMS message from this little dictionary. And lastly, this is our Twilio number that we are using for sending out messages. Once this is done, we are actually posting back a confirmation to the Slack channel saying what the Twilio response had been. And this is where you will see on Twilio that queued response. So this means that Twilio has accepted the request to send an SMS message, and it has queued it up for execution. In my case, it executed almost immediately. So that's why I got that message almost in real time. And this is how that slash command looks like. So very simple piece of code. Once you start using that Slack integration, you really can focus purely on writing code. All the concerns that serverless addresses in the regular serverless scenarios have been taken care of for you. So as it turns out, we have made this integration available to anyone. So you can just head to webtask.io/Slack and install it on your own Slack team. This is completely free at the moment. It has also been accepted into the Slack app directory last night. So you can also fetch it from there. And lastly, I wanted to spend a few minutes talking about how that entire webtask infrastructure is hanging together. How did we build it? What are the kind of core architectural pieces of the solution? Our main focus in the development of webtasks was to provide a sandboxed environment for executing custom code. So the central concept in this entire architecture is what we call a webtask container. Webtask container is a named entity that provides a certain isolation guarantees for executing code. Every webtask that you run must execute in a very specific webtask container. Now, if you have two webtasks that execute in the same webtask container, they may or may not be isolated from each other. So they may be running in the same process, in the extreme. However, if you're running two webtasks into different webtask containers, they are guaranteed to be isolated in terms of in-memory state, CPU, disk, and network. In terms of the implementation, webtask containers at a certain level map to Docker containers. So Docker containers are the kind of implementation mechanism behind webtask containers. However, none of the Docker concepts percolate to the top of webtask. So as a user of webtask, you really only think about webtask containers without really concerning yourself how this is implemented. At some point in the future, we may switch to something other than Docker containers while still preserving the same guarantees. So let's look at the runtime. How does the runtime function? When a request arrives to the system to execute a certain web task, it first lands in what we call a webtask runtime. Webtask runtime conceptually acts as an HTTP reverse proxy. So it'll look at that request, and the first thing it'll take note of is the webtask container name within which to execute this piece of code. Once that webtask container name is identified, the runtime will find out if there is already a Docker container associated with that webtask container. If there is, that request will simply be reverse proxied to that Docker container, which will execute that webtask in this isolated environment and send back the result to the caller. If there isn't a Docker container associated with that webtask container, the runtime will pick up a fresh, unassigned Docker container from a pre-warmed pool of Docker containers. So one distinctive characteristic of this design is that we actually maintain a pre-warmed pool of Docker containers that you can very quickly assign when the request comes in. The reason for this optimization is that the original scenario for which we have been designing webtask was targeting web-facing scenarios. So we had to execute some custom code. At the time, there was a human sitting in front of the browser looking at a login dialog and watching an hourglass spinning and waiting for it to close. So it had to be fast. We couldn't afford to have him waiting for seconds before closing that dialog, because that would be a very poor user experience. So a lot of optimization went into ensuring that our cold startup latency is as minimal as possible. That's why we have come up with that idea of keeping pre-warmed Docker containers, which we can very quickly associate with an incoming request in case it addresses a webtask container that hasn't been used for days even. One interesting implication of this design choice, having a pre-warmed pool of containers, it only makes sense to have pre-warmed pool of whatever if that whatever is uniform. So one implication of this design choice is that all web tasks on our platform execute in the same execution environment. And that execution environment consists not only of the operating system, but also of a large number of Node.js modules that just are there on the platform already pre-installed. We have about 900 modules pre-installed on the webtask platform that you can simply go and use from your code. Now that number, 900, how did we come up with that? This is an interesting aspect too. There are over 400,000 modules on NPM today. So how did we come up with 900? We actually analyzed statistically the data from NPM. As it turns out, over 80% of downloads from NPM is made up by less than 700 modules. So you just decided to kind of follow that Pareto rule and took that 700, installed it on the platform, and this satisfies the vast majority of scenarios our users ever encounter. From time to time, we'll get a request to add yet another module, which we have a way to do, but we found that this was a very pragmatic design choice to make. Basically, package the most commonly used modules and ship them as part of the platform. In addition to the webtask runtime, the webtask system also consists of the webtask management APIs. So this is an HTTP server that exposes all the endpoints that both WT-CLI as well as that web-based editor is using to create webtask, list webtask, operate on secrets, and so on. And I think this pretty much summarizes the high-level architecture of the system. So please remember to try out the Slack integration. We found that it empowered our team in a great way, and we hope it will help you as well. And beyond that, I would like to open to questions. Thank you.